do what's on the board. All right, so if we look at question 1, all right, name the group. What group name is arsenic in? What do you call that group? Nitrogen family. All right, what's the group number? 15. What's the period number? 4. All right, what type of element is it? Is it a metal, non-metal, or metalloid? Metalloid. What is its state? Solid, liquid, or gas? It's a solid. All right, what's its oxidation number? -3. And how many outer shell electrons does it have? It has 5. You should be able to do that with every single element on the periodic table based on what we color-coded yesterday on a periodic table. Okay? If you can't, you will not pass tomorrow's quiz. Okay? So that's simple. Are you with me? Okay. Princess, here's your other blank copy from yesterday so that you can catch up on what we color-coded. Is there anybody else who was not here yesterday who needs a blank copy of the table to do what we did yesterday? You can color-code it based on what somebody else did. You can get it from the video. I don't care as long as you catch up. All right, so draw the shorthand for SG. Where's SG on the periodic table? It's at the bottom, okay? So if you look, oops, apparently I still have glass over here. I didn't get up yesterday. All right, yep, there it is. So SG is right here. So at the end, an up one, so RN in brackets. What comes after it? 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, and 4 and 5. So we're going to come back down and we're here. So that is 7S, 1, 2, 6. This is D. So D, how far before I hit the little circle? 1. Down, we hit 5. F, all the way across. So that's 14. Back up to the little circle. And I have 6D. How many more? 1, 2, 3. So 6D3. What am I going to do with these and those? Combine them. So I have 6D4. Get rid of one of them. And I don't care who's first and who's last. You could have just as easily combined here and gotten rid of this one. And I would not have cared. Questions? Anybody? Questions about shorthand notation? Because we don't have any actual homework to go over. Just take it real quick, see if I can get that up. Now, you can get out notebook paper if you prefer lines. It does not matter to me. Get up there. All right, but if you don't want lines and you're perfectly fine with no lines, you don't need any paper. I'm providing it all. Even the periodic table. You may have no periodic tables on your desk. Absolutely nothing. All right. Since the view, we'll move back a little ways. Periodic tables that I'm giving you, you may write on. Okay. Or the counter, I don't care which. All right. We do not need these periodic tables back. So feel free to write on them all over the place, number them up the way you want to, mark them up so that you put your numbers on them. If you don't write on it, of course, I'll take it back so that I can recycle. But if you do need to write on it, feel free. Okay? Make sure when you do the quiz that the correct notations are used. If I say orbital notation, that you draw orbital notation. If I say shorthand, you draw shorthand. You cannot change up the notations I'm asking for. Okay? And of course, this is your first quiz on the new core. Here's a periodic table that we talked through yesterday. You can catch up on it after a while. Because they've already put all their notes up, so. Maybe you're still working. Okay. working, maybe you're still working now. Well, that's better. What do you mean you're still working? More to go. So is the lighter the only one still working? If I see that there's something that's quiet, I might not off. When you're locked up again, please say your periods around. That's good. I'm a little surprised last 2 days. It's so quiet in here. Since you're the personnel will be transplanted in the second period.
Yeah, I did it for the business.
Oh, okay. As long as it was for a good reason.
Yeah.
Makes all the difference. You done now? All right, pass your quiz papers to the front. I don't need anything but your quiz paper. All right? Periodic tables I don't need unless you did not write on them at all. Okay? If you didn't write on it at all, I'll take it back. If you did, and you don't want it, put it in recycling. All right? If you want to keep the periodic table, you can do that. Now, those of you who did not take the quiz, like I told those people yesterday who were going to be out for the PSAT today, don't wait long to make it up. Okay? I'm going to pick on Princess for a minute. I don't need this unless it's part of your quiz answer. Oh, okay, so I need to staple it to the quiz?
Yeah.
Imagine having to do this like Princess when she came to make up that lab from the very first week of school when she came and did that last week. Imagine having to do this quiz the week before exams or in December. How much of this are y'all going to remember in December?
Nothing.
Exactly. At least on the exam, if you get it as multiple choice. This is all free response. You're not going to remember this in December. So Princess and Janai, don't wait till December to come make that up, okay? Now, find your notes. We're going to finish up the last of the notes for our test that's coming up. You can write in your mind. Yes, ma'am. No, we did not take the quiz yesterday. So this is the first grade of the new quarter. And you have a quiz tomorrow on the stuff that color coded yesterday. I'll be here today. I will not be here tomorrow. Okay? You need a periodic table. Is what you need. You got one? I gave it to you? Okay. You can either get it from somebody else in class and take a picture of theirs and color code it that way, or you can watch the video. Either way.
I watched some of the video. I didn't.
Okay. Yeah. Most of what you need is there tonight. It was actually not a bad day to be out because it was largely just color coding and getting the parts of the periodic table. It's very straightforward. Okay. It's probably one of the easiest days to have to make up being out.
Yeah.
Yeah. I mean, it's literally just memorizing where the liquids are, where the gases are, where the solids are, where the metalloids, non-metals are, which group the name of group 1 is, group 2 is, that kind of stuff. So it's a pretty good day to be absent. I was supposed to have a Kahoot today. Why is that not up there? I did not write that up there. I should have. All right. Y'all need laptops? We're going to practice some things on the periodic table that you took yesterday. Those of you who weren't here, of course, will not be able to. I mean, you can play. You just won't know a whole lot.
Oh, we're doing it on the periodic table.
Yeah. This is 101. All right, anybody need a laptop? Do I need to get anybody a laptop? Okay, second period I do, which is why I'm asking. All right, put your names in. It's only 15 questions, just to practice what we did yesterday. in here. All right, who am I waiting on? Anybody?
Me,
Are you?
me as well.
Who's Lolly?
Me.
Okay, that's why I was asking. The number 14 is the atomic number. Okay, anything I put in parentheses is the atomic number to make it easier for y'all to find it. Y'all can use your notes. Alright, silicon happens to have the same group number as atomic number. Alright, silicon, when you look, is in group number 14. If you look at, I don't have my meter stick out to be able to point. The silicon is in this group right here, so remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? Some people do that. All right, so let's read a picture. What's the name of the colored group? Good. I hope that would have been 100%. Good. Alright. I have a meter stick right there. Long enough I can point with. I'm going to go grab it because I'm going to need it. I'll just haul around with these things. All right, so if you look at hydrogen and helium, all right, this is period 1. This is period 2. This is period 3. This is period 4. Okay, so calcium is in period 4. Good. Hydrogen and helium are liquids. C, carbon is a pencil, so it's not a liquid. Good. All right. Arsenic is here on the staircase, so it's a what? It's metalloid. All right. Calcium is over here in the blue, so it's a what? It's a metal. All right. That's why those answers are wrong. At least y'all know the colored sections so that you're just able to read your table and get them right. Carbon we just said was a what? Is a pencil. All right. It's also over here on the right of the staircase, so it's a non-metal. Sodium is over here in the blue, so it's a what? Metal. Chlorine is over here on the right, so it's a non-metal. And then helium's a noble gas. At least none of y'all picked that one. Okay, good. One electron in the outer shell. Remember, we count back 1 through 8. 1, 2, 3, 4, 5, 6, 7, 8. So everybody in group 1 has how many? 1. Sodium's in group 1, so it has 1. And we're going to do more of that in a couple minutes. Good. I only put those kind of questions in there tomorrow. We're going to be good. Okay. Iodine's a non-metal. It's on the right. All right, lanthanides are here. All right. See, E is right here, so it's lanthanide. there is in period 1, 2, 3, 4, period 4. Last question. Which one's gas? Okay, the two of you pick carbon again. Carbon is a black solid. It's a pencil. It's not a gas. All right, and the lithium is a metal, so it cannot be a gas. Okay, good job. All right, you will put your phones up. We're going to take notes the rest of the period. And how excited you are about that. But it's the last notes in this unit. We're going to practice some stuff that's going to set some of you over the edge tomorrow, but it ties in some things. And then we'll see where we are tomorrow as to whether the test is Friday or Monday. All right. Today, we're going to talk about my title people, the relationship between outer shell electrons and oxidation numbers. That's the title. That's what we're doing today. So yesterday I put the actual oxidation numbers and the actual outer shell electrons on your periodic table. And I told you we'd come back and talk about how they're related today. It plays into our next unit. But since we put it on the table, I talked about the relationship in this unit. Now, we're going to talk about what's called main group. Okay? We're only going to work with what's called main group. The main group are the S and the P blocks. Okay? So we're only going to do this for groups 1 and 2 and groups 13 and 18. So, we're not doing this for all 18 groups on the periodic table. We are going to talk about 8 groups on the periodic table. Okay, so you have to know the relationship for just those 8 groups. Now, we're going to start with group 1, and we'll do a lot for group 1 to explain how it works, and we'll do less for each of the groups until you get the pattern. Once you understand the pattern, then it's a whole lot easier to talk about it, and we'll do a lot less as we go across the periodic table. So, to explain how this works, we're going to start with group 1. Okay? So in group 1, hydrogen has an electron configuration of 1s1. Lithium has an electron configuration of 1s2, 2s1. Sodium, I'm going to start with shorthand because I don't want to write out a whole bunch. Let's see. I'll do the video. And that'll be enough for what we need. Got enough pens over there?
A lot of them got two. Yeah. Take it. You get a lot more in there.
I'll have my son decide to clean out his room this summer. You would be surprised. 3/4 of what's over there is his, yes. He's been collecting school supplies since he was in elementary school. He decided to become a minimalist this summer, much to my pleasure. right, so if we look at the electron configurations, what is the highest energy level in hydrogen? Heard it out there, 1. Okay? So if the highest energy level in hydrogen is a 1, what's the highest energy level in lithium? What's the highest energy level in sodium? And the highest energy level in potassium? And the highest energy level in rubidium? Okay, so from there, what do all 5 of those elements have in common? All right, they're all in S sublevel. How many electrons do they have in their outer shell? 1. Okay, so they all have 1 electron in their outer shell. Okay, now that is why they are group 1 elements. Now, people ask all the time, why is hydrogen, which is a gas, in group 1? Tell me now why hydrogen is in group 1 when it's a gas. It has 1 electron in the outer shell. It is that simple. Hydrogen has 1 electron in its outer shell. All elements with 1 electron in the outer shell are group 1 elements. No other group on the periodic table, no other element on the periodic table has 1 electron in their outer shell. That's why they're all in group 1. Are you with me on that? Okay. Now, the goal of all elements is so many electrons. Anybody remember from middle school or another science class how many? It is 8. Very good. So I must have had a good teacher before you came to me. Huh? She was okay? Okay. Glad to hear that. I wouldn't want you to give good reviews or anything.
Why? You want to be the best?
Huh?
You want to be the best?
Ask her if she had before she came in.
Huh?
I had you last semester.
Oh. I just want to put my other skill.
No. So, we were talking about Central. We were at Central, weren't you? Yeah. I'm talking about them. I was talking about me. Now, so the goal of all elements is to have 8 electrons, which is why we'll do bonding after we do the periodic table, because they all want 8 electrons. So, the question is, how do these elements in group 1 get 8 electrons? All right? I'm just going to arbitrarily pick sodium because it's not too big, it's not too small. So it's a nice one to draw that y'all aren't, oh my God, this one, I got to draw what? All right, so we're just going to use sodium. Sodium has how many electrons? Can anybody tell me? I got a periodic table handy. Can you see one? Yeah, well, I want all of them because we're going to draw the Bohr model.
6, 11.
How'd you get 6? You got to have one that's got atomic numbers on it. Yeah, that one doesn't have any numbers on it. Yeah, got to have one with some numbers on it. All right, sodium has 11 electrons. All right, so there's this nucleus because we don't care what's in it right now. Okay, so on the first ring, first energy level, how many sublevels can the first energy level have? Have 1 sublevel. What's his name? That's the same first sublevel. Oh my God, we're in deep doo-doo for this test, people. The first sublevel can have what name? S. Okay. Oh, y'all are so quiet. I can't hear the little weak. What if I talk? And y'all trying to hear me teach? There was some confidence out there. S. All right. So how many electrons can S have? 2. That's 2. Good for you. Can have 2 electrons. So, did any of y'all learn in another science class that the first ring could have 2 electrons on it? Okay, that's why they taught you could have 2 electrons. Because the first ring can have how many sublevels? 1. And what's the name of that first sublevel? And how many electrons can be at S? That's why you learned that rule. Okay? So, on the second ring, how many sublevels could you have?
6.
Whoa! All right. So try this again. The second energy level can have how many sublevels?
6.
N equals 2. How many sublevels could you have? 2. What are their names? S and P. And what do you put in front of the S and the P?
Why wouldn't it be S and D?
It has to be in order.
Has to be in order.
Oh.
So 2S and 2P. Okay.
Oh,
It's just
okay.
confusing.
I was-
Because on the periodic table is
The order on the periodic table is irrelevant. The sublevels have to come S, P, D, F. They have to stay in order. So 2S and 2P. So how many electrons can go in 2S? How many can go in 2P? 3 lines would be how many electrons?
6.
So 2 plus 6 is how many? 8. So on the second ring, you can have how many electrons? You can have 8. Anybody ever learn that?
No.
Okay, last week we said N equals 2, and I asked you how many electrons you could have if N equals 2. Okay? And if N equals 2, y'all said there were 2 sublevels. And you said it was 2S and 2P.
Oh,
And S could have 2, P could have 6, for a total of 8. That's what I just asked you.
Oh,
Okay? I can't write it down. I'm not going to write it down that way on the test. Because I'm not. Okay? So I said out loud, in a second energy level, how many electrons can you have? Okay? I said if N equals 2, or second energy level, how many sublevels are there? And y'all yelled 5, 3, and then y'all got to 2. So once y'all got to 2, I said, great, what are their names? And I got 2S and 2D. Okay? It's 2S and 2P, yes. So 2S can have how many electrons? And 2P can have how many electrons? That's how you got the answer. Are you with me now? Okay. So we have 2 and 8, which is 10. I still need 11, so I need how many more electrons? So on the third ring, I'm going to put how many? Okay. So this is what sodium would look like. Now, sodium wants 8 electrons on this ring. But it only has how many? Only has 1. So it has 2 choices. It can gain 7 electrons, or it could lose 1 electron. So, what would be easier for the atom of sodium to do to get to that magical number of 8? It's much easier to lose 1. Okay? So, gaining 7 would be hard. Now, some of you are like, I don't get it. Why would it be hard to gain 7? Imagine I sent you out in the courtyard during lunch, and I said, go out there and gain $7 or give away 1. What would be easier during lunch? To give away $1 or gain 7 more out there? Probably easier to give away 1 than it is to get your friends to donate $7 to you. Okay? So, same thing happens here. It's much easier to say, lose 1, so we'll still have that ring. And then we have 1, 2, 3, 4, 5, 6, 7, 8. So this becomes the new outer shell, and it has 8 electrons in it. Because this one we did what with? We lost it. We gave it away to somebody. We don't care who right now. We'll talk about who it went to when we do bonding. Now, how does this affect the oxidation number? That's where we're going with this. If we lose one, we have 11 protons. What charge do protons have? So we have a plus 11. Electrons have what? We lost one, so instead of having 11, we have how many now? We have 10 electrons. So in math class, if you add this together, what happens if you have plus 11 and minus 10? What kind of one? A positive or a negative? You have a positive 1 oxidation number. So whenever you lose electrons, what do you have more of? Do you have more protons or more electrons? More protons, you wind up with what kind of oxidation number? Positive or negative? Positive. Does that make sense? Whenever you lose an electron, what do you have more of? More protons or more electrons? You have more protons. Protons are positive, which is why you have a positive oxidation number. You have more protons. Does that make sense? Okay. All right. Everybody with me on that? So, if we look at group 2, for example, everybody have what they want, or do I need to wait? Yep, I can wait. About now. Okay? So, if we looked at group 2, for example. All right, and we have beryllium. I'm only going to write 3 this time. All right, and we look at those 3. What do they all have in common?
The S and the 2.
The S and the 2. So what can you tell me about their outer shell? 2 in the 2 in the outer shell. All right, so if we look at beryllium, its highest energy level is what? 2. And if we look at magnesium, it's what? And calcium, it's a what? So if we look at those, the highest energy level here shows that we have 2 electrons, 2 electrons, 2 electrons. So you see what you were trying to say there, Elena? They all have what? In the, okay. So every element N and G2 stands for group 2 has 2 electrons in the outer shell. That's why they're in group number what? 2. If they didn't have 2 electrons in the outer shell, they wouldn't be in group number 2. It's that simple. Everybody with 2 electrons are in the outer shell is in group 2. Now, everybody in the transitions also has 2 electrons in their outer shell, but they have that whole D block thing going on. Okay? Group 2 doesn't have that whole D block thing going on. Now, I'm just going to draw Mg, because again, it's sort of in the middle of the road. It has 12 electrons. It's just like sodium, so the second ring will have 8. All right, so if I have 2 on the outer shell, all right, and it still wants 8, but this time I have 2 on that outer shell. What are the 2 ways I can get 8?
Plus 6. Minus 6.
Okay, so I can gain 6, because 2 plus 6 will give me 8, or I can lose 2 is what they said. Now, again, I can't do both, so I got to make a choice. Which one requires the atom the least amount of energy or effort? Atoms are like people. Okay? You're going to do the thing that's going to require the least effort. What will require the least effort? Losing 2. Okay? So, gaining 6, way too much effort. Losing 2 requires a lot less effort. Less effort is good. So, what oxidation number will I be if I lose 2?
10. Okay,
Oxidation number.
2.
Okay, the oxidation number is a 2. And because I lost 2, it's what? Positive or negative? Okay, hold on. So, I have plus 12 protons. I lose 2, which means I have how many electrons now? I have 10 electrons. So what charge will I be left with? Positive 2 when I add. So I'm going to have a positive 2. All right? Anytime you lose electrons, you have a positive oxidation number because there are more protons. Okay, that's the rule. You have a positive oxidation number because there are more protons. Does that make sense? Okay, you have more protons than electrons. That's why it's positive. All right, we're there. Don't need to wait. Yes, no?
No.
You're done right. You just don't do it. I'm not interested in what you don't want. I'd like to be home in my pajamas, but clearly I'm not there. All right, so when we jump over the transitions to go to group 13, I'm going to do 2 this time. Boron is He, 2s2, 2p1, and aluminum is Ne, 3s2, 3p1. All right, let's see. Let's see if I have. Oh, it just sucks. No, that's only the first period. That don't help me. All right. It's going to be depressing when none of your children are ISS for the day. All right, so. No, I didn't say that out loud. So. What? I was disappointed that none of my children were in ISS. It's only one class period.
You might have to. You might have to dance it.
It could. That's the way to be positive. It could happen. All right, so.
Isn't you people around time? Would we all be here all the time? This year?
No, it's not. I was like, There's no volume up. It's like no speed.
Like the urgency. It's literally like, it should not be, exactly, that's.
They're like kindergartners, only in large bodies.
Could be a 4 feet.
Very large.
Alright, so if we look at this, alright, what can you tell me about the outer shell? Tell me that. 3 electrons. Alright, so if they have 3 electrons in the outer shell, what do they have to do to get to that magic number of 8? What are the 2 options? Zyra, what are you going to say? Say it. It looked like those lips were going to move. What do you think? Tell me what you think. You don't get shot for being wrong. What's one way we can get to 8? Add 5. Okay, so we can gain 5. What's another way we could get to 5? All right, get to 8, right? Lose how many?
3.
Not 2. Lose all 3. Okay. So we could gain 5 because 3 plus 5 will give you 8, or we could lose 3 electrons. Which one will give us the least amount of effort? Losing 3. Okay, losing 3 is easier than gaining 5. So if we lose 3, which oxidation number works? Is it a positive 3 or a negative 3? It's positive 3. The oxidation number is positive 3 because you said lose. Lose is positive. The reason is, I'll just pick aluminum. Aluminum has 13 protons for aluminum. Now, if we lose 3 electrons, how many electrons would we have if we lose 3? So we have 10 electrons, right? So if we have 10 electrons, what would we get when we add these things together? Positive 3. That's why it's positive 3 when you lose the electrons. Does that make sense? Okay, I got a yes from Serenity. What about some of the others?
Yes.
Okay. Now, what's going to happen when we get to group 14? All right, and I'm just going to pick carbon. I'm only going to write 1. All right. What's its outer shell have? It has 4. So what happens when you have 4 electrons in the outer shell? How do we get to the magic number of 8? You can do what? Either way. Okay? We can either lose 4 electrons or we can gain 4 electrons. Now, who's to say that losing 4 is easier than doing what? Gaining 4. Is it easier to lose or gain? No. So if you remember what we said yesterday, this is the oxidation number that we said was what? That's right. Because we have no way of knowing which one is easier to do. To either lose 4 or to gain 4. Okay? It could be either one. Are you with me on that? Now, we're at the halfway point. We now have 4 electrons in the outer shell. So in the next group, we're going to have how many in the outer shell?
5.
5. Everybody got what they need, or do I need to wait? Got it? Okay. So in group 15, I'm just going to pick phosphorus. All right. We said there were 5 electrons in the outer shell. Okay. So, how can I go about getting 8 if I have 5? Am I going to lose 5? No. Okay. I can choose to lose 5, or what's the other way to get to 8? Gain 3. So, what's easier this time? Gaining 3 is easier. It's much easier to gain 3 than it is to lose 5 if you're an atom. Okay, it might not be easier to go out to the courtyard and gain $3, but it's easier as an atom to gain 3 electrons. So, what's the oxidation number going to be if you want to gain 3 electrons? What? -3. Okay? Now, the oxidation number is -3. Now, the reason for that, if we take phosphorus, it has 15 protons. If I gain 3 electrons, how many electrons will it have? We'll have 18 electrons. Now, if you're sitting in math class, what happens when you add those two numbers together? What do you get? You get a -3. Okay, so when you gain electrons, that means there are more electrons, so you end up with a negative oxidation number. Okay, anytime you gain electrons, there are more negative charges, so you're going to be a negative oxidation number. Does that make sense? Yes, no, maybe?
Yes.
Okay, so everybody there? Okay, so the last 3 groups. We can do these in the few minutes we have left. So, group 16. Okay, let's do sulfur.
You jump from group 1 to 13.
Because we jumped over the transitions, I said we were only going to do main group. Okay, so that has how many electrons in the outer shell? Okay, so we have 6 electrons in the outer shell. So this time, what are my options to get to the magic number of 8? Okay, we can gain 2. Or we can lose 6. What's easier? Gaining 2. So, what's my oxidation number going to be if I gain 2? Okay? Questions? Any questions? Can I turn, or do I need to wait? All right, group 17. Group 17, if we take, let's do chlorine. Ne3S2, 3P5. How many electrons are in the outer shell? All right, so we have 7 electrons in the outer shell. So what are we going to do to get to the magic number of 8? Going to gain 1. We will gain 1 electron. So that means our oxidation number is a what? What's our oxidation number going to be if we gain 1 electron? It's going to be what? -1. Okay? Because we gain. It's negative because we gain. 1 because you said 1 electron. Now, what's going to happen when we get to group 18? It's going to be full, so the oxidation number is going to be what? 0. Okay? And I'll let everybody catch up before I write that down. And we will summarize this tomorrow in a chart, but so it's a little more succinct to study for the test. Everybody got it? All right, so group 18. It has, let me not write this as I can do it in normal gas this way. HE, 2S2, oh, sorry, 3S. 3S2, 3P, 6. That way it's written in shorthand. I did the wrong noble gas. I need any. There we go. All right, now we have 8 electrons in the outer shell. So, what do we know about gaining and losing? Won't do either. Okay, so it will not gain or lose. So the oxidation number is what? 0. Okay, group 18 is what we're going to refer to tomorrow as stable. Okay, it doesn't react with anybody. Okay, it's perfectly content with its 8 electrons. The other elements we're going to talk about who is and is not reactive. That's the last piece we need to do. And it will not take us very long. And then we're going to work on applying the quantum numbers. Now, those of you who are not going to be here because you're on a field trip, you really need to pick this paper up off my desk, because if we still test on Friday, you need to have done this before we test, because probably 25 questions of the test is on being able to apply these quantum numbers. So make sure you fetch one of those. Your homework tonight is the front side of this paper, 1 through 14.
And the quiz tomorrow is on this.
The quiz tomorrow is on that periodic table, that's correct.
So just memorize this.
Yes. Oh, that's for all 4 of you back there. That's for everybody there, including Danielle. Roberto is in your row.
Are you gonna give us another chart to write on for tomorrow?
No, you're going to draw off your table in your notebook. It's not hard. I will show you how to do it. All right, so I don't have anybody in here that's going on the field trip tomorrow needs one of these. Come get it. Come on, people. Bell's going to ring, y'all still just sitting there. Doing nothing.